Section 5.3 is on multiplication of decimals. This is fairly easy. The rules are pretty simple. You're going to multiply as if you would integers or whole numbers. Then you're going to place the decimal point in the product in the answer so that the number of decimal places equals the combined number of decimals in the problem. So if we have this problem, we're going to multiply as if this were 8. 32, 8 and 3 would be 11, 72, 73, 8 and 7 is 15, 8 and 1 is 9. Now, when we look through where the decimal point was originally, we have 1, 2, 3 places and 1 place. So in our answer, it's going to be the combined number of decimal places. So this is 4. We have 1, 2, 3, 4, which seems to be a pretty reasonable answer because we've got about 12 and we've got not a whole, not quite 12. We've got just 8/10 of that. Okay, if we were going to do this one, we'd multiply as if there are whole numbers. So we're going to multiply through by 1, 7, 9, 1. Then when we multiply by the 4, we have to either leave a space or a placeholder. 4 times 8 is 28. Carry your 2. 4 times 9 is 36, 37, 38. Carry your 3. 4 and 3 would be 7. We'll add those together. And we have 1 place in the top, 1 place in the bottom. So we would have 2 places in our answer. The combined number of decimal places. So we have 2 places would be 80, which is about 20 times 4. Now, we keep doing this, doing things by the power of 10. Powers of 10 would be 10 to the first power, 10 to the second power, 10 to the third power, and so forth. This is equal to 10, this is equal to 100, this is equal to 1,000. Remember, the number of zeros equals the number, the exponent. Multiplying 10 moves the decimal point 1 place to the right. We know that. When we were in elementary school, we thought about adding a 0, which really, if you had 6 times 10, this is 60, but we know the decimal point is here, and we've moved it 1 place to the right. It was here, and we've moved it 1 place to the right. Multiplying by 100 moves the decimal point 2 places to the right because we have 2 zeros. Multiplying by 1,000 moves the decimal point 3 places to the right. So we're going to move the decimal point to the right, the same number of decimal places as the number of zeros in that power of 10. So if we multiply 14 75 hundredths by 10,000, we're going to move this decimal point to the right 1, 2, 3, 4 places. So we have 2 within the number, and we're going to add 2 more zeros. So now we have 1, 2, 3, 4. So our answer is 147,500. Here we're going to multiply this decimal, 64 10,000ths by 100. 2 zeros, so we're going to move this decimal point 2 places to the right. Well, we don't need all those zeros, do we? Probably wouldn't write those. But our answer is 64 hundredths. Now, if we multiply this negative number, we've got a negative times a positive, so we know our answer is going to be negative. And we're going to move this decimal point to the right, 1, 2, 3, 4, 5, 6. So we have 1, 2, 3 places in our number. And we're going to add 3 more zeros. So now we have 1, 2, 3, 4, 5, 6 places. So 8,271,000. So now if we're multiplying by these decimals, this would be 1/10, 1,000th, and so forth. You're going to move the decimal point one place to the left because we're multiplying it by 1/10. We're finding 1/10 of the number, so that's going to be smaller, so we're moving to the left. If you're multiplying by 100th, you'll move it 2 places to the left. And if you're multiplying by 1,000th, you'll move the decimal point 3 places to the left. You'll move the decimal point to the left the same number of decimal places as the number of decimal places in that power of 10. So, before we were marking with zeros, now we're marking decimal places. So, if we have 62 and some times this number, we have 1, 2, 3, 4 decimal places. So we're going to move this decimal point to the left 1, 2, 3, 4 places. So our answer is going to be that number. Tenths, hundreds, thousands, 10,000s, 100,000s, millions, 100 millions. So 6,274 hundred millions. Was that what I said? Thousands, 10,000s, 100,000s, 10 millions. Okay, now we're multiplying by 1/10. We have 1 decimal place, so we're going to move this decimal point to the left 1 place. 796 and 53 hundredths. Now this is a negative again, so we know we're going to have a negative, and we're going to move this decimal point to the left 1, 2, 3, 4, 5 places. So we're going to have this 0 and 4 more. And then we'll have 0057. So, it was here, and we moved it to the left 1, 2, 3, 4, 5 places. We can add this little courtesy 0 if we want. Remember, when we're multiplying by these powers, that are like 10, 100, 1,000, then we're counting zeros. When we're multiplying by this, we're moving it by counting decimal places. Now we're going to kind of combine a couple of these skills. We're going to be what they're calling naming large numbers. In a lot of writing, especially in newspapers, you'll see a large number that's written like this: 92 and 9/10 millions, 800,000, 472 billion, and we use words for that. So now we want to write it as a numeral. So we know that this is 92 and 9/10 times a million. So when we multiply by a million, we're going to move the decimal point to the right 6 places because we have 6 zeros. So originally the decimal point was here, but we're moving it to the right 6 places. So we have 1, 2, 3, 4, 5, 6. So 92 and 9/10 millions would be 92,900,000. If we want to write 800,000 just strictly as a numeral, most of you might know that it is this, but we're talking about 8 times 100,000. And this is 100,000. We know the decimal point's here. We're going to move it, the decimal point, to the right 1, 2, 3, 4, 5 places. So we have 5 more zeros. There's our decimal point that you don't see. 472 billion. We're going to multiply 472 times a billion. Here's the thousands, here's the millions, this is the billions. So we're going to move the decimal point to the right 9 places. So it was here, so we'll have to add 9 zeros in order for it to be here. We're going to work again with the area of a rectangle, because sometimes these measurements are given in decimals, and so we'll be multiplying decimals. This is our formula. The area equals the length times the width. So now we have a few problems to work. The most famous painting in the world is the Mona Lisa. The dimensions of it are 30 inches by 20 and 875 thousandths inches. So one's going to be the length and one's going to be the width. It doesn't matter which one, because we're in multiplication and the order of those factors doesn't matter. So we'll write our formula. This is our formula. Now we're going to substitute, and like I say, it doesn't matter which you have where. One of them's 30, one of them's 20, and 875,000. And now our answer, we're finding area, so area is always the number of square units. So we're measuring it in squares. So we would multiply times 30. So we'll have 3 times 5 is 15, carry your 1, 21, 22, 24, 25, 26, 0, and 2, and 3 times 2 would be 6. Now, how many decimal places do we have in our problem? Well, we don't have any in the 30, but we have 1, 2, 3. So we need 1, 2, 3 in our answer. And we want to label that. And you can write it with this 0 on the end or not. That won't show if you work that on your calculator. And this is going to be square inches. So you can write it like this, you can write it like this, but it has to be square units. These are little units that are 1 inch by 1 inch by 1 inch that we're going to cover the painting of. I doubt they'll let us do that, but. Okay, our next problem is about the IMAX movie screen. This should be the word the. Museum of Science and Discovery. It's 18 meters by 24 and 4/10 meters. So we're going to find the area. So we'll write our formula. And now we're going to substitute. It doesn't matter which one that you choose for the length and which one you choose for the width. But now we're going to multiply those. So I'm going to multiply as if they're whole numbers. I'm going to multiply through by 8, 32, carry your 3. 32 and 3 would be 35, carry the 3. 16, 17, 18, 19. Now I'm going to multiply through by 10, so I'm going to have a 0. 4, 4, 2, and now I'm going to add these together. And now I have 1 decimal place, 0 decimal places, so in my answer I'm just going to have 1. So the answer is going to be 439 and 2/10. This is measured in meters. So we're going to have square meters or we're going to have square meters. How you do that is up to you. How you want to, which label you want. But you need to have one of those labels. It's not meters. We're not measuring length. If it were perimeter, we'd be measuring length. But it's area, so we're filling in this with squares that are 1 meter by 1 meter by 1 meter. Next, we're going to look at circles, and we're going to look at the circumference. This is the distance around the circle, and the area, which is how many squares would it take to fill in that circle. So we have our formulas. The circumference, of course, is the distance around the circle, and we have 2 formulas that we can use. One is the circumference is equal to pi times the diameter. The other one is the circumference is equal to 2 times pi times the radius. Pi is a Greek word, and it's written with a little symbol like that. That's the Greek letter. And in English, we would write it in words, in letters like that, just like this is the letter B, and if we wrote it in words, we would write it like that, or maybe with another E, depending on what you wanted to do. So what you have to realize is that the diameter is all the way across the circle, and the radius is just from the center. So if you use this formula, you need this measurement. If you use this formula, you need this measurement. So we first are going to work a little bit with that. If we want to find the length of the radius on this figure, this is all the way across, and the radius is only half. So half of this, the radius would be 23 centimeters. On this one, we're asked to find the diameter, which is all the way across, but we're only given a radius, so we're going to have to double that. We're going to have to find the diameter, we'll have to double the radius. So 3/4 and 3/4 would be 6/4, right? Or 1.5, or 1 5/10. And this is probably the easiest thing for us to work with. So if we want to find the circumference of a circle, I think our book tells us to use this value for pi, and this is approximately. Pi is a magic number that the Greeks found long ago, and it is the distance around the circle divided by the diameter, and you come out with a little more than 3. This is a number that never ends. It goes on and on. Many calculators have a key for pi. On my calculator, it's right here. And if I push that key, whoops, I guess I better clear it first. If I push that key, I don't know if you can read that or not, but it's a very long, it fills up my entire display. So depending on how many places your calculator will show, this calculator, I think the directions say it shows this many places, but actually it uses a few more when it calculates. So what we're going to do is we're going to round this to hundredths, to 3 14/100, and just use that one so that we all get the same answer, just to make it simpler. We are estimating, even if you use your calculator, you'll get an estimate, but it may not be exactly the same thing. It may be off a little bit. So we are going to use 3.14 for pi. So if we want to find the circumference of a circle, this is the diameter, so probably we'll want to use this formula. So we'll write that formula. We're going to substitute, and remember we're going to use 3 14/14, and then we'll multiply by the diameter, which is 4. So if we do that multiplication. 16 carrier 1 is 5, is 12, and we have 2 places in our problem, so we have 2 places in our answer. And remember, we're just measuring like with a string around the outside, so this is just going to be plain centimeters. On this problem, we are given the radius, so we'll probably use this formula. Or you can double it and use this one. It's all be the same. So if I use this formula, and then I substitute 2 times, and we're going to use 3.14 for our value for pi, times the radius, which is 8. So if I multiplied that, I can do it on my calculator. I would probably multiply these two in my head times 3.14. That's just fewer things for me to punch in, and my answer would be 50 24/100, and we're talking about feet in this particular problem. Next, we're going to look at the area of a circle, and that means the number of squares that would fit in the circle. And that would be pretty hard to figure out just by putting squares in there, because you're going to have parts of squares all around the outside because it's a round shape. So we're going to use a formula. We're going to use a formula to do that, and this is our formula. Area equals pi times the radius squared. So you're going to have to use the radius. You're going to have to use the radius. Even if you're shown the diameter, you're going to have to use the radius. So 4 centimeters is the diameter. The radius would be half of that. So on this particular circle, the radius would be 2 centimeters. Because you're using the radius, you have to use the radius measurement in the circle. So we'll write the formula, pi r squared. Now we'll substitute, and again, we'll use 3.14 for pi. The radius we said was 2, and we're going to square that. So in other words, we're going to be multiplying 4 times 3.14, which you can do, or you can do it on your calculator. And I'm getting 12 56/100. Now, we're measuring area, so we're measuring it in squares. This is measured in centimeters, so it's going to be square centimeters. Remember, if you use the exponent, it goes with the measurement, not with this number. You don't want it over 144. What you want is the measurement, the unit, to be square. You're measuring squares that are a centimeter on each side. Okay, this one, again, we're going to write the formula. And this is the radius, isn't it? It's from the center to the outside. So we'll be able to substitute 3.14 for pi. The radius is 8, which we have to square. Okay? So when I figure this, I'm going to use my calculator, and I'm going to do this part in my head. That's 64. Everybody okay with that? 8 times 8? Okay, so I'm going to multiply 3.14 times 64. You can put in 8 squared, but every time I put in another number, I somehow hit the wrong thing. So I like to do as much as I can in my head. So I am getting 296 hundredths. Again, these are square units. This is measured in feet, so it's going to be square feet.